Alright, good morning from the Four Sigmas. Today we are doing the absolute zero experiment using the Pasco equipment. So to start off, we're going to, of course, get a display. So we're going to do one graph and data table. And we'll select our measurements here with temperature on the bottom. We'll switch this to Kelvin, because that's what we're going to be looking for, is we're looking to extrapolate absolute zero out of our experiment here. And our vertical axis will be absolute pressure. And we're going to get rid of this. This is actually a previous run. We're going to do another one for you guys here. And we're going to do likewise over here. And now our displays are ready to go. Before we actually start our experiment, we're going to have to change a few settings in our recordings. So down here with our frequency, we're going to take this down to 5 Hertz. It just makes it a little slower so we don't have data going all over the place. And then for this experiment, we are going to do manual mode. In Capstone, this is called keep mode. So down here, instead of continuous mode, we're going to do keep. And so what this does is you'll see the preview of where the data point is on the graph when we are in preview, and to keep where a data point is, you'll simply press keep sample and it will record in the data table and keep that point on the graph. Now I'm going to turn you around here so we can see our setup, and we have Ryder over here showing our constant volume sphere. Temperature and pressure inside the sphere will change. We have it at room temperature right now. And then we have a cold bath and a hot bath. Alright, so we are going to start recording data here in a second. Ryder, we're going to do room temperature first. So I've started recording the data, and we can see that the data is moving around the tiniest bit, but it seems to be pretty well at room temperature. You see, we're not getting anything beyond the decimal place in variation. So we're going to actually keep that number. So we're going to hit keep sample. And now, Ryder, I'm going to ask you to put it in the cold bath. Now we can see the temperature is dropping pretty quickly. In the Kelvin scale, we should get to, theoretically, about 273. Hopefully we'll be close to that. And you can see actually the line gets more linear as we go along. And that's good. That's what we want to see. Alright, and it looks like our temperature is stabilizing once again. As you can see, we don't have a lot of variation in our decimal places here, so I'm going to go ahead and keep this sample as well. And now we are going to submerge the apparatus in the hot bath. So Ryder, if you will. And we can see the temperature shooting up as we put it into the warm water. And as expected, we are seeing the line linearize again as the temperature increases. And if we take good data, these lines will actually overlap each other. You can see the lines are getting closer still. So we're going to wait a little longer. And I'm going to keep it right about there. So we're going to actually stop recording now because these 3 points are actually all we need to extrapolate our data. So we're trying to extrapolate absolute zero, something that is not, capable of being observed in the laboratory, but is known because we can extrapolate it. So what we're going to do is we're going to apply a linear regression to our data here, and we're going to look at our b, because b would be the y-intercept. Theoretically, this should be at 0. It's actually at -4. Conditions aren't perfect in this room, but this is actually better than the data we took in our first run, so we're improving. But yeah, so this is meant to model absolute zero. We are pretty close to absolute zero at -4, but that is it. And again, we can show up here where we do our linear regression. And yes, Tony's telling me we can auto-scale the graph. Not much change there, but you can see the lines overlap pretty well. And sure, so we can zoom in on the 0. And we can see that we're almost at 0 pressure and 0 temperature, just a little bit off. Again, laboratory conditions, especially in a classroom setting, aren't going to be ideal, but this is pretty close. So that's it for today. Thank you, and have a great day.